So in the last session we discussed about the average values. Now let us use the same problems and same concept to reproduce the RMS values. Okay. So let me write here some formula of the RMS value. So let us say in generally, if we have a function f of t, we can say f suffix RMS, capital or small, it's your wish. What I'll do is that simple task, that I'll take exactly the average value expression, What is the difference is that I need to add one root. I added one root for this entire thing. I need to
And
square
create
the
here.
function. These are two
Yes,
changes
sir.
you need to do. Now, so I will do same exactly that. So previously we already evaluated the average values. So this entire work is already there. So it has merged over here. So let me make it small, this one, or just I will do one task. So 1 second. So otherwise, let me undo. Just 1 second. I hope I got all values. Yes, so I got. So now just I'll write here simply f RMS is equal to. So what I'll get is this. I already have. So no need to write again. This is what f RMS. Otherwise, you can put somewhere wherever you want. Yeah. So this is what f RMS. It's over. Then next is this, every calculation remains same. Once you see the RMS value calculation, what you need to do? You need to identify the time period. You need to observe what will be the function, that is what v of t, 7 for what? 0 to 1 and 1 to 2. So it is minus 5. Then as like in the average values, so what we have to do? So let me take this. So this entire thing I will take it. So this entire thing going to be repeated up to this, more or less the same thing. So let me take this entire thing for the RMS values, just for simplicity. I'll take one fresh problem also, just I want to show that. So the once you get the average value, getting RMS value is very simple. Add a root, okay, then spare this function, then root will be there as it is. How we evaluated average value? We splitted the integration. So let us split again. So splitting and sparing the functions. So let me add with the different color. Then splitting is over. So square root is added. Then square of this, square of this. Now evaluate this. Tell me how much is this? Evaluate this integration. So you will get. So how much is this? Simple that. So 49 into 1 minus 0 is 1. So 5 square minus 5 is 25. 2 minus 1 is 1. So 25. How much is this value? So 49 plus 25 divided by 2. 49 plus 25 divided by 2. Is that correct? That's 7.
Yes, sir.
That is 7, sir.
So square root of that. Square root of answer is 6.08 volts. This is what the RMS value for this waveform. Okay, just yourself go through these things, you will understand some extent. So what we did for average value, additionally what I am doing is just adding root and square of these values. Okay, for the same waveform, so which we taken in the last session, I am trying to evaluate the RMS value now. So this waveform, right? Okay, so let me consider here. So let me remove this section. Why? Because this is not required. So that I'll get some space here. I'll write. So tell me now, what is the RMS value? VRMS square root of 1 by 2 integral over 0 to 5t whole square. That's all. See, compare the average and RMS. Just I added extra square root and this function square. Then how much I'll get? Check it. So this I'll get as
12 point.
how much? 12 point. Let me check. So because so 0 to 2, yeah, so into 0.5. So total value is 5.77. Whether anybody got or not, check it. RMS value, volts. Is that correct? Anyone got it? Okay. If you want only integration corresponding thing, so I will tell you that 8.16, but 1 by root 2 will be there. Okay. I evaluated root also. Somebody don't want root also, I can give you 200 by 3. Only integration part. Okay. Anyhow, you try in this way. Okay. Similarly, try for this same waveform for this problem. Average values we already found it. So now let me create some space here so that no disturbance, right? As long as no disturbance, no issue, right? So now what we do? Just let me take this entire expression. Why? Because it is very much helpful. Now I'll edit this. I'll say that, sorry. So this is RMS, for which additionally I am adding root. I am making square of every function. How much is this value? Evaluate and tell me. So let me take this again in this way, 1 by 4 into this integration. Then tell me how much we will get. Try all of you. This is 5 by 3 into x square. Square is important. And limits are 0 to 3. And then plus another integration. So for this integration it is 5 t minus 20 whole square, and limits are 3 to 4. And anything else?
సార్ ఎక్స్ రావాలంటే ఏం టైప్ చేయాలి సార్?
Alpha x.
సార్
Type alpha.
రావట్లేదు సార్ అలా చేసినా కూడా.
Is it? So okay, I'll show you that after some time.
ఓకే సార్.
So for the time being, evaluate this. Let me evaluate. So integration part, let me check first, then I will add 1 by 4 and etc. You can also check. What I got is this 1 by 4 into this entire integral part I got as 100 by 3. Anyone got this value? Just correct me if anything is wrong. Then square root of answer into 1 by 4. So 5 root by 3, which is equal to 2.886 volts. Okay. Right. So I asked to find the average value for this waveform in the last session.
సార్
So anyone did it?
0 సార్.
0.
ఎస్ సార్.
Very good. So usually here I want to introduce one more concept here. So see here that I hope up to this RMS evaluation is clear for everyone. If that is clear, I will proceed further. So these integration mathematical things that can be learned, that is not a tough task. There is no engineering involved in this. So concept is very important. How are we evaluating RMS value is very important. Okay. And this average value is very important for us. Quickly let us see. I hope all of you might be evaluated in this way. In order to evaluate the average value, what we need is time period and integral over 0 to t, and f of t means here v of t
V of T dt.
dt. This might be the formulation which you used, right? So then for this you might be observed what is v of t. You might be written v of t maximum value is 5 and v of t 5, and this is a sine pattern, so you might be written sine. Omega means 2 pi by t. So how much is the time period that you can observe? Time period is this much, 2 seconds. That is what the t. So 2 pi by 2 into t. So plus 0. So this is what the v of t simply, which is equal to simply 5 sine pi t. This is the mathematical expression for the given waveform. Now integrating this, what does it give? Let us see. 1 by 2 integral over 0 to 2 5 sine pi t. So check it, how much we will get this. Remember, integral of either sine or cosine over one complete period will give the 0. Okay. So this, even if you want, you can verify by this integration. So what is the sine integration?
Minus cos, sir.
Minus cos pi t. So, but we did the integration with respect to time. So pi is there. So divided by pi. What are the limits? 0 to 2. Now, if we complete this 5 by 2 pi, so minus cos 2 pi, I am substituting in place of t value 2. So 2 pi minus minus plus cos pi. Now see how much is cos 2 pi? Cos 360 degrees.
Sir,
Cos 360 degrees is
1, sir.
1. So minus is already there. So minus 1. Cos pi is cos 180.
Minus 1, sir.
Minus 1. Something is wrong then? No, this is 0. No? I am very sorry. I am really sorry. This limit is 0. Why I will get 1? So pi into 0, right? So this, I am really sorry that here cos 0, no? Why I got pi? Okay, that is my mistake. It is 0. See, lower limit is 0, not 1. Okay, so cos 0 is 1. So overall 0. Got the things? Then what is the necessity of evaluating the average value? If it is this kind of waveform, we will get the 0. So for this we should inspect one more interesting thing, that see here, whenever, listen all of you very carefully, whenever positive half cycle positive half cycle area is equal to positive half cycle area is equal to negative half cycle, or just if these are mirror imaged means one can understand it look like same copy but in negative side. So this kind of waveforms we call as a symmetric waveform. Symmetric means positive and negative both are in same way. So let me write for symmetric waveforms, for for symmetric waveforms, the average value, average values are evaluated only over a half time period, or half interval t, half time period. So or a half time period means half means t by 2, or you can write. Let me remove this instead of that confusion. This is very important statement. Wherever you see symmetric waveform, don't say that average value is 0. Blindly one can say average value is 0. No need to do even this exercise. Instead of that, what we need to do is that we should evaluate the average value over a half cycle instead of full cycle. Okay, so this is very important statement for all symmetric waveforms. What is mean by symmetric? Positive and negative are similar in nature, completely similar. Area also equal value. Such waveforms we call as a symmetric. Positive half cycle is similar to the negative half cycle. Such waveforms we call as a symmetric. For such a waveforms, the average value is evaluated only over a half cycle. So let me write instead of half time period, half cycle. Okay. Now we evaluate the average value. Again, do this exercise. VAVG is equal to 1 by t by 2. Half interval means t by 2. Integral over 0 to t by 2 v of t dt. Why I am modifying my formulation? Instead of over one complete time interval, I am taking t by 2 everywhere. Why? Why? Because I observed that waveform is symmetric. So I should proceed in this way. Okay. So now see that how much we will get. So t by 2 is 1 second, 0 to 1 second, 5 sine, tell me, pi t dt. Quickly evaluate how much we will get. This is 5 into same expression, that what we will get, cos pi t by pi over 0 to 1. Tell me how much is this value. So this is equal to 5 into, or 5 by pi into, so minus of cos pi. Okay, so minus plus cos 0. Okay, cos 0. Is this correct? So this is 5 by pi. Cos pi is minus 1, so 1 plus 1 is 2 into 5 by pi. Why I am writing like this is, so you can understand little later. This is 10 by pi is the average value for this sine wave. Right? Right. So finally, let me make one more important argument about this. If we have v of t as some generalized function as like this, Vm sine omega t, what will be the average value, VAVG? So that average value is equal to 1 by, as because this is a symmetric waveform, so I will go with 1 by t by 2 integral over 0 to t by 2 Vm sine omega t into dt. So complete this integration. So let us see what kind of value we will get. 2 by t integral over, or 2 Vm by t integral over 0 to t by 2 sine integration, or let me write here sine. So omega t dt. In the next step, let me write 2Vm by t. So tell me how much we will get. You know that omega is equal to 2 pi by t. This I will substitute later. So here tell me that minus cos omega t 0 to t by 2, and this integration is with respect to dt. So I will get omega in the denominator divided by omega. So if I will bring these things, 2Vm by t into omega, omega means 2 pi by t, okay, this omega. So next is minus cos omega means I am substituting 2 pi by t into t means t by 2. Got my point? This is cos minus minus plus cos 0. This is what the entire integration. Just once you go through, you will understand carefully. So t will get cancelled and 2 also will get cancelled. What is left out is Vm by pi here. Next is here also you can see what are the things will get cancelled. 2 and 2 and t and t and cos pi. Cos pi is how much? Minus 1. So minus minus plus, so plus 1. So see that 2Vm by pi. See that average value, did I got 2Vm by pi or not? See here. That's why I kept 2 into 5 by pi. So what is 5 is maximum value. See here. What is the maximum value? 5. So 2Vm by pi is the average value for any sinusoidal waveform. You blindly remember this. V average is equal to 2Vm by pi. In the same way, just let us quickly do the RMS value also. V RMS is equal to what I will do? Square root of, so 1 by t by 2 integral over 0 to t by 2. So for RMS value, whether you consider full cycle or half cycle, it doesn't matter. So instead of all these by 2 by 2, so I will consider t only. Okay. So I will tell you why it is not a matter in case of RMS value, whether it is symmetric or not symmetric. So can somebody identify why it is not a matter? Tell me.
Sum of the all circles కదా sir.
Not sum of the all circles. In RMS values, what are we doing is that we are squaring this function, right? Here, see this. We are squaring this function and adding root. Yes or no?
Yes sir.
As the result of this square, all these negative half cycles will become positive. So no question of becoming 0. That's why whether you consider half cycle or full cycle for a symmetric wave, so it is not a matter in evaluation of the RMS value. Okay. If somebody want, you can consider only t by 2, t by 2, all as like average value. So or you can consider directly t. So Vm sin omega t whole square dt. So you need to evaluate this. So let us evaluate quickly and wind up the session. So see this, what we get. So 1 by t into, so let me write here Vm I will bring out of the integration, that it becomes Vm square, then sin square. So can I write sin square theta as how? Sin square theta as 1 minus cos 2 theta by 2. Okay. So Let us write this. Let me take one more step. 0 to t sine square omega t dt. So this is equal to Vm square by t. What I'll do is that integral over 0 to t sine, I will write 1 minus cos 2 theta, means theta means what here? Omega t, 2 omega t by 2 into dt. So just if you go through these mathematics, you will realize that this is Vm square by t, and this is integral over 0 to t 1 by 2 dt. One more integration is there, minus integral over 0 to t cos 2 omega t by 2 dt. Is this clear? Any confusion here? No, right? Right. So now, so if you have somebody already studied in mathematics, sine or cosine function over a one complete time interval goes to 0. Remember this. If you want to evaluate, we already did that. Okay, you can try. So what is cos 2 omega t integration? That you evaluate. Cos integration is the sine. Then divided by 2 omega. Already 1 by 2 is there. That also you take care. So sine 2 omega t by 2 omega will come. Then substitute the limit and check it. You will get 0 definitely. If not, come back to me again. So we will see that. Okay. That part goes 0. Then what is the left out thing? This. So what I will get here? Let me check here. Vm square by t. So 1 by 2 is there. Integration of constant is t, and if we substitute the limits, what we will get is capital T. So ultimately what I will get here is Vm by root 2. So for a sinusoidal waveforms, for all kind of sinusoidal waveforms, the RMS values are Vm by root 2. Blindly you can say, once you know the peak value, you can say RMS value. Once you know the peak value, you can say average value. You no need to look for all other things, so time period, etc. It's not required at all. For whom? Only for sinusoidal. Okay, don't say that for this kind of waveform, so peak value is 10. So 10 by root 2 is RMS value, which is a blunder mistake. This is not a sinusoidal, so I cannot apply that formula over here. Okay. So in that way, one can evaluate the average values and RMS values for a sinusoidal waveforms also. I had taken a generalized waveform here, that so V is equal to Vm sin omega t means how does it look like? Look like this. This is the time axis. This is the waveform as like this, etc. and so on. It will continue. So this is the voltage whose peak value is Vm and negative peak value is minus Vm. Remember, both must be equal, then only this formula is valid. If this is Vm, this is 2 Vm, it is not valid. Okay, this is time period t, 2t, etc. and so on. Okay. So for this kind of waveforms, the RMS values, average values are 2 Vm by 2 Vm by pi is one thing, and Vm by root 2 is another thing. Okay. Thank you.